Hello everyone, welcome to another video from Advanced Math Tutors. Today I wanted to bring you one last integration by parts example, but you should commit this example to memory because this is a professor's favorite question for integration by parts. Professors love giving their students this questions when they teach integration by parts, so I wanted to present to you the right way to do it and give you the correct solution, alright? The trick is that you have to make a substitution first and then use integration by parts. So I'll show you what I mean. Let's say y is equal to the square root of x. And I use y because I'm going to use u and v when I do the integration by parts. And I didn't want to use the same variable twice. All right. So by implicit differentiation, we know that dy is equal to the derivative of root x, which is 1 over 2 root x dx. All right. But look, there's a root x here and a root x here. But root x is equal to y, so we can rewrite this dy with the y in there. So let me just show you what I mean. So here we have dy is equal to 1 over 2, but then the y is equal to root x. So this is just a y, and then there's a dx. All right. And now I'm just going to solve for dx. We have dx must equal, bring the 2y to the other side, and you get 2y dy. All right? And so we can put in, we can substitute the y in for this root x, but then we can substitute all of this in for dx, all right? And let's do that. So when we make the substitution, we have the integral of the cosine of root x is equal to y, cosine of y, and then dx is equal to 2y dy, all right? So let me just 2y dy. And now, this is starting to look like an integration by parts question. It's just now the variable is y, not x, all right? So let's bring this down a little. And I'm going to pull the 2 out of the integral, so I'm just going to rewrite the integral real quick. We'll say this is 2 times the integral of, why don't we put the y first, just to make it look nicer. Y times cosine of y. All right, and now we have the dy. All right. So let's apply integration by parts. So remember from last video, whenever you see a variable alone, you should try to make u equal to that variable. So let's say u is equal to y. All right. Therefore, du must equal dy. All right. And so now our cosine, or I guess our dv, will be equal to cosine y dy. And that's okay because we know what cosine, we know how to integrate cosine y. All right. And so now v is equal to sine y. All right. And now let's just plug everything in. We have this 2 is multiplied by everything. And so now we have uv, which is y times sine y minus the integral of v du. So we have the integral of sine y, and then du is equal to dy. And so we're just integrating sine y, which is equal to negative cosine y. But since there's this negative here, we can just say that that becomes a positive cosine y. All right. And so now this is looking like our answer. So all of this becomes just positive cosine y. And so now I'm just going to distribute the 2. And so we have that entire integral was equal to 2y times sine y plus cosine y. And this is the answer. Now, if we want, we can revert back. Remember, y was equal to x, so we can throw back x into this equation, saying y is equal to the square root of x. And so now the answer becomes 2 times the square root of x times sine of the square root of x. And now we add back cosine of the square root of x. And of course, plus c. That's our answer. And you should commit this to memory because this is a very common problem in any Calculus 2 class, all right? In the next video, we start partial fractions.